Hello, NR322. Welcome back to Lesson 7a. This is the second half of Lesson 7a, where we will focus on selections. So in the first part, we were looking at a typical scenario where you download data and then you need to get it ready for analysis. So you might need to clip the data down because it's for a larger area than you need. You might need to project your data because very often when you download data, it's in GCS, Geographic Coordinate System, but you want it in a projected coordinate system like UTM. But now we're looking at the third part of the scenario where maybe you have data for lots of different categories and lots of different types of features, and you only need one type. Or there's a lot of attribute information in with the data, and you need to narrow it down to find exactly the criteria that you are looking for. So to do that, we can pick out data based on attributes in the table. So we do this using what's called a query or a selection. When you do a query or selection in ArcGIS Pro, it's called select by attribute or select layer by attribute. And it's using a type of expression called SQL, Structured Query Language. The general format for SQL is that you want to select features. That's what the asterisk is. It represents features. Select features from the layer that you choose, where, and that's kind of the first part that you don't really look at in ArcGIS Pro, but select features from a layer where some field has some type of value, and it could be denoted by many different types of operators. So field operator value. So it could be aquifer name equals Edwards, or area is greater than 50, or population is less than 1,000,000, things like that. So the operator is the type of comparison or equality that you're trying to look for. So you can do a lot of different things with SQL, anything from basic equality, greater than, less than, things like that, not equal to. You can get a little bit fancier, like the like operator is a case-independent string comparison with wildcard. So it's a way to use a wildcard. So instead of looking for a literal, for something to be exactly a certain value, it allows some flexibility. Like if something might be lowercase or uppercase, or if something might be spelled differently, like there's an E on the end because someone had a typo, things like that. In is another really handy operator, and that's to look for a list of items, and we'll look at that in the demo. You can also combine expressions together to make one larger complex expression using and, or, not, or like. And or are pretty typical if you want to combine two together. There's also different wildcards. If you're using the like operator, you need to use a wildcard. And there's different wildcards. It could be an asterisk or a percent sign or an underscore. And it depends on what exactly you're looking for. We'll take a look at that in the demo as well. For your reference in the slides, if you have the actual slides, here we have two links for you to the help so that you can take a look at a little more information about SQL statements. Here, like most of the slides now for the rest of the semester, there's a link here to a demo video. So if you don't like this video and you want some more, there's another one for you. But here are some examples of what SQL expressions look like. So here we're continuing on with the demo of the oil data from the COGCC, the Colorado Oil and Gas Conservation Commission. And here we're taking a look at some well data, and maybe the well is in, the well falls in a certain aquifer, and so we're looking for, what aquifer things are falling in. So aquifer name equals Edwards, and the area is greater than 2.0. So here's a combination where we're doing multiple things in one, and we're using and. So here's our field name, here's our operator, and then Edwards is the value that we're looking for. And then we have another field name, another operator, and another value, and they're connected with the and. So by saying and, it means we're looking for both conditions to be true. We're looking in two different fields, and we want them to be true in both. Notice also that we have Our text is enclosed in single quotation marks. Numbers do not get a quotation mark. So keep that in mind. When you build your query with the query builder, these will automatically be correct for you. If you have a shapefile, it will use a double quotation mark. If you have a geodatabase, it doesn't need any quotation mark. Number 2 is an example of using the like operator. So if we don't feel like spelling out all of Mississippi because we might spell it wrong, you can use a wildcard. So state name like Miss %, will get anything that starts with MISS. Here's an example where we're actually doing math. So we're saying find any features, select any features where the value for population divided by area is less than some value. So now we're actually doing math on 2 fields. It's going to do that math internally and then compare it to the value we're looking for. Number 4 is an example of in. The in operator is a really handy one if you want to look for a list of values or multiple values. It just makes it shorter and easier. Your SQL statement will be shorter and easier to work with. So here, state name in, and then you provide the list of items that you want to look for, the list of values that you want to look for, and you provide each one enclosed in their single quotation marks, separated by commas. And then all 3 of them are in parentheses, and that's how the in works. And then the last one here, number 5, again, we're doing a complex query. In this case, we're looking for wells where the oil field name is either Freeman or Vance. So name equals Freeman or name equals Vance. If you're going to use or, then everything on either side of the or has to be a complete SQL statement, which means that you have to repeat this name equals for each piece. That's why in is really nice, because then for in, you can just list the values without having to say name equals this, or name equals that, or name equals that. In ArcGIS Pro, this is what it will look like. This one here is what it looks like in ArcMap, so it's a little bit different, but you're still building a query using your field name, and operator, and a value. In ArcGIS Pro, you tell it what layer you want to select on, and then you pick your field name, the operator, and the value using little drop downs. So it's even easier to build. Even though you're building it like this, even in ArcGIS Pro, what you're building behind the scenes is something called an SQL expression. So behind the scenes in ArcGIS Pro, this is what you're actually building when you do that. So it will generate this SQL expression with the correct formatting, with the equal sign, with the quotation marks. It'll put that in for you. So if you want to make complex queries and combine multiple clauses or expression statements or pieces of your query into one tool, you can do that using and or. So here's an example. Select features where name equals Freeman and name equals Vance. And then the other side here, name equals Freeman or name equals Vance. If you had a field in your table that represented something, and in our data we have a field called field name, and that's the oil field that the oil is in. If you have multiple values coming from the same field, then a single feature can't have 2 values within one field. So and wouldn't really make sense. So typically, if you want values from the same field, that's what this first bullet is saying. If you want values from the same field, typically you will use or. If you want to look for values from different fields, then typically you'll use and. But you have to look at it and think about it and just think about the logic of it and figure out which works best for you. One thing that you might want to do with SQL statements is look for what's not equal to something. So rather than selecting everything, you might want to select what's not. So you can use the not operator and look for, if you wanted everything that wasn't the USA, you could say your query expression would be not country equals USA, or not elevation is null. So that's an easy way to find the flip side of what it is. If you're looking for everything except something, you can use not. Another thing to keep in mind is if you have complex queries, you can nest multiple things together so that the expression is evaluated in a certain order. So you can use parentheses to force that ordering of your operation. Okay, so let's go into the software right now. Oops. Here we go. So now we're in ArcGIS Pro. We just did a little brief overview of selections, and some of it should be a review for you. So if I had my points, so here I have the same well points and roads from the other day, from the other video. I'm going to open up my attribute table so we can take a look at the attributes that we have for our wells. We have a whole bunch of stuff in here, but the ones that we might want to look at might be facility status. Scroll all the way over here. Then we also have field name and siting type, and also spud date. That was like the date that it was created. So thinking about those, let's find all of the wells that are in the Wattenberg field, the oil field. So for that, we're going to go up to select by attributes right up here. Going to pick my layer that I want to work with. I want to make a new selection. The other ones are if you want to build off of a previous selection, so you can make a selection grow or shrink by building on it. Right now I don't have anything selected, so I want it to be new. Then I'm going to hit new expression. Right now I want to find all of the points in my wells layer that have a field name value of Wattenberg. So I'm going to go to where field name is equal to Wattenberg. So that is how I select it in Pro, but behind the scenes, if I flip this little SQL toggle, it's actually building an SQL statement. This is an SQL statement or an SQL expression with the correct formatting. SQL is a standard language. It's called structured query language. It's a standard language with standard expressions that are used not only in GIS, but in any database. So learning a little more about SQL and what it can do is a really good skill to have, especially if you ever do anything with databases. So I'm going to hit run now. And it selected all my points. I can see them on the map. And these are all the wells that fall within the Wattenberg oil field. There's a lot of them. Let's go back here. Let's combine two clauses together. So maybe I want to find all of the ones that are in Wattenberg that are also planned. So under my siting type field, I have different categories, and some of them are planned. So I want to know which ones are planned for the Wattenberg field because that's what the EPA is maybe keeping an eye on. So I'm going to go down, I'm going to go to add clause. And let's just fill this in first, and then we'll figure out if we want and or. So and siting type is equal to planned. So now do I want and or? Am I looking for values from two different fields or within the same field? I want it to be and because they're coming from different fields. I want it to be both Wattenberg and planned. So I'm going to keep this as and now I'm going to hit run, and we'll see this is going to reduce a lot. So now these are the ones that are both Wattenberg and planned, and those might be the ones I want to focus on. Okay, let's go back to the slides now that we've played around a little bit with basic queries. So now let's say we had all those planned wells in the Wattenberg field, and we want to know which wells are within a certain distance of something. So select by location is another way to select where you're not using the attribute table and criteria in the table to make your selection. You're using spatial relationships. So it could be a distance from something else, or it could be containment. It could be something is inside something else, or something is adjacent to something else. So examples of this might be looking for wells that are within a half mile of a road, looking for elk points, like we use those elk points in Lab 6, that are within Rocky Mountain National Park, which streams are contained by a certain watershed, which houses are in a certain fire risk area, which might be a polygon. So select by location is how you can do that. And again, we have this thing called a selection method. So you can create a new selection, add to, remove from, or select a subset of, and you can make selections build on each other. If you want to watch another demo video, here's a select by location demo video, but I'm just going to hop back into here and we are going to make another selection. So let's select again. We're going to select all those ones that are in Wattenberg and planned, and site type is planned. So these are the ones in Wattenberg that are planned. Now from these, what we want to do is figure out which ones are too close to occupied structures or in a vulnerable area. So I'm going to close my table and I'm going to zoom in a little bit. So now that we have our selected wells where we're looking at, they're kind of hard to see here, but the blue points are the ones that are in Wattenberg and planned. Now what we'd like to do is find out which ones fall within a vulnerable area or are too close to buildings that we might want to not actually put a well there. So what we want to do is of these ones that are selected, we want to select the ones that fall inside. So you can see there are some outside here and some inside. So we want to get the ones that are selected currently and also within the polygon. So for that, we're going to do select by location. So what we want to do is select features from our wells layer that intersect our layer here, which is occupied structure and vulnerable areas combined 25-foot buffer. So that would be this one. And what we want to do now is we already have a selection in place. What we want to do is subset the selection. So only look at what's currently selected and then select based on that. So now we're going to hit run and we'll see that these ones that fall outside should drop away, leaving us only with the ones that are planned and in Wattenberg that fall inside the polygon. So now that we have that, we can do a right click and we can turn these into their own layer by right click, selection, make layer from selected features. And then we can turn off the original, and these are the ones that are of interest to us. So between select by attributes and select by location, we can whittle down all these hundreds of thousands of points only to what we are looking for. So we kind of already did some of these steps here, but I wanted to end with a demo where we go through how to answer some questions. So if you wanted to find out something like which wells are injecting, that would be a pretty straightforward question. You would just set up a query where you look for the facilstat column equal to whatever value. Which planned wells are in the Wattenberg field? That's the one that we just did. Now let's take a look at number 3. Which wells are owned by Noble Energy Services? So let's go back. Which of these wells are owned by Noble Energy? If we take a look at the table, we can see that there's an operator field. So we want to find ones from here that have an operator of Noble Energy. So let's go back to select by attributes. And we're going to make a selection on our selection layer. We're going to make a new selection on the selection layer. And we're going to look for operator is equal to Noble Energy. So if we hit run, now we can see in our table there are 24. So there are 24 planned wells in the Wattenberg oil field that are too close to an occupied structure. And so these are the ones that we might want to go contact Noble Energy and talk to them about not doing them. Let's go back to our list here. Which wells are within 0.5 miles of a road? We just did that one. That was select by location. And again, if you want to find the wells that meet an individual criteria, you can just make a new selection on each one. If you want to find the wells that meet all 4 criteria combined, that's where you do the select subset from current selection. So you can do multiple criteria at a time and then keep whittling away at it. Now, number 6, how do we set a flag value so that we can easily find those ones? So in our table right now, here we have our 24. Maybe we want to set a flag, like we want to make a new field where it says of concern. So wells of concern, we want to add a 1 or something. So for that, we could add a field. And wells of concern. Oh, it's too long. I'm just going to call it concern. So wells of concern, we'll make it a long integer and save this field. So all of these ones that are selected, we want to put a 1 in there because those are the ones that we're concerned with. So for that, we can just do a quick calculate field. Put a 1, hit run. And now all of those 24 wells that we are concerned about now have a 1 in there. So these are the ones that we might want to follow up on. How do we export these selected wells to their own layer? That's really easy. So what we just did, from the original, we did a right-click selection, make layer from selected features. That's actually just a temporary layer. It's not creating a new feature class on the hard drive with that. But if we wanted to, we could do a right-click, data export features. Data export features will actually launch the feature class to feature class tool where you can give it a new name and a new output and whatever, and that'll create a new output for you. And then the very last one on here, which wells are in one of these fields, Fort Collins, Loveland, and so on. So if you're looking for if you're looking for multiple features, like multiple categories in one field, that's where you use in. So let's go back here. I'm going to turn this one off, turn this one back on, and clear my selection. Okay, so what we want to do is find multiple features from different categories. So for this, it would be select by attributes. So on my layer, I want to make a new selection, new expression, and I'm looking for multiple values. So for field name, I would use includes the values. So field name includes the values. Notice that now I get a checkbox. So now I get a checkbox instead of having to do an individual SQL statement with multiple ands, this and this and this and this, or ors. Now I can just pick from the list. So let's go down. We'll pick Fort Collins. We'll pick Greeley. We'll pick a few that I know are around here. Laputer and Wattenberg. Wattenberg is a big one. All right, so I picked a few different oil fields from that list. If we take a look at the SQL statement behind the scenes, this is what it builds us. Field name in, and then our list of values that we chose with single quotation marks separated by commas with parentheses. So this here turns into this. And now I can select for multiple features in one statement and makes it really easy. And if I hit run and zoom out, I'll be able to see which ones it picked. Okay, that's not very exciting. But that's how you would do it. So this little demo, the answers to it are on the next slide, so you have that for your reference. And that's all I had for right now. If you want more practice with queries, there's a really great Esri web course called Querying Data in Pro. The link is linked here, or you could just Google it. It's only about a half hour. There's some really great videos and text to read, plus some activities if you'd like to do it. It is actually part of Lab 7 to do the videos and text, so I highly recommend that. And then here are some links again to those demo videos if you want to go over these a little bit more. For your own benefit, we have the recap the concept slides and the answers. So take a look at this and quiz yourself and see if you know all the answers. And then lastly, we are getting into analysis now. So I want to get you starting to think about this concept of a workflow or planning your GIS workflow. And I'd like to compare this to the idea of like writing a paper. You start with an outline. Before you grocery shop, you make a list. Or maybe you only do that if you're as OCD as I am, but they're really good ideas and they keep you organized. Anytime you start a GIS project, or even just a simple, a few simple questions that you need to answer, it really does help to organize yourself and think about what is your question, what data do you need, and what tools or methods are you going to use. So start thinking about that anytime you're faced with a question, like these ones from the SQL demo. For each of these, you can create a very small little workflow for that. So we're going to talk about this more in the coming days, in the coming weeks, but just to get you an idea. So think about that, and we will be having Lab 7 will be this week / next week, where you'll get to go through all the things we just talked about in Lesson 7. Quiz 4 is due April 8th. Lesson 7 B and C will be coming soon. Good luck. Let me know if you have any questions. Thanks for watching.